Corey to split the pages. That's what you needed, was the equations, right?
Alright, so we are wrapping up all things quadratic. I'm going to do, as I said, a recap of some of those things. Hopefully, we recognize our quadratic equations. Guys, I cannot emphasize this enough. If you don't practice with the equations, it's hard to remember them. If you don't practice with the check your understanding questions that I have given you, it's going to be hard to be successful. If we miss a day of school, whether it's because we were feeling sick or even if we were in class or we just missed, we got to make sure that we watch those videos to catch up on what we are missing. It's hard to miss 2 whole days on the block and stay on top of things. But all the key features of those quadratic functions. So these were the official pages that we should have already had torn out. We're mostly going to focus on 69 and 71 today. Okay, so let's do this quick recap. First things first. Which quadratic equation do I have right here? Vertex form? Okay. So what is that vertex form so I can write it above really quickly?
Oh, A parentheses X minus H parentheses plus K.
Okay. Now, when you talk about vertex form, there's 3 features of that parabola that we need to be able to see immediately. Amber, give me one of them. Give me one of them. The features that I need to be able to see. Okay, what are the 5 features? Let's start there. Concavity. Vertex.
Y-intercept, X-intercept.
The vertex. Y-intercepts. X-intercepts.
Who was another one?
Line of symmetry. Okay. Which of those 5 should I be able to see right away without any work from the vertex form? I want you to remember it's the vertex form. So what do I need to be able to see? Vertex. What else?
Concavity. Concavity.
And
yeah, that's what this is.
okay. Now I want to remind you. So one, we should have. All right, this real quick.
Okay, just take it.
We have these graphic organizers that came from the textbook. Each of them has a different form at the top, right? Vertex form here, standard form, and factored form. It even has the equation with these methods down there. You should also have your Freire models with check your understanding questions, all those things, if you want to use it. But we have vertex form, we have concavity, we have line symmetry. Now remember, can I find the other features? Yes, that's what Friday was all about. Do I have to, though, for the assessment?
No.
No, right? For this unit, you need to be able to find those features so that you can sketch a graph. And so when I look at this, what's my vertex?
Oh, plus 1 will positive 1.
That's the whole vertex?
Positive 1 and a negative, positive 3.
So remember, with the x minus h, I need the opposite. With the plus k, though, it is what it is.
Yeah.
Now, concave up or down? Like a... Guys, I cannot tell you, in first block today, we had their test on this stuff. I cannot tell you how many people it broke my heart that they told me concave up, and then they drew this.
Anything honors?
Advanced.
Oh, advanced.
That's concave, like a, guys, concave down like a frown, concave up like a cup, okay. So concave up, that's all you would have to have. Well, and don't forget, line of symmetry is pretty straightforward because, what does the line of symmetry have to go through?
Line.
It has to go through the vertex, right?
Yep.
That's why it's x equals h, or x equals 1 in this case.
Yep.
That's my line of symmetry. That's a very strong sketch of this quadratic function. Now, next unit is all about learning how to find the x-intercepts. We're not doing that at all right now, unless it's which form. Which form shows x-intercepts?
Factor.
Factored form, right?
Yes, sir.
But how can I always find the y-intercept? Because that's a small, easy extra detail.
Looking at it.
Not just looking at it. what do we know about every y-intercept that has and will ever exist?
Oh, the x is 0.
The input is 0, right? So I can always find my y-intercept.
The y-intercept right there would be 3, wouldn't it?
No, that is the most common mistake students make. 3 is the y value of the vertex, not the y-intercept. Notice if my input is 0, what's my output? 7. So 3, 4, 5, 6, 7. So 0, 7 is my y-intercept. Do not forget the y-intercept, that x is what? The x is what for a y-intercept? 0. Guys, you can also look at the graph, because where's the y-intercept located? On the y-axis? Isn't x equal to 0 on the y-axis?
Yes.
Okay, right? X is equal to 0 on the y-axis. It's not random. It is what it is. Okay, so right here, though, I do want to point this out. We're going to quickly recap a couple of details that will help us. Which again, Mr. Avi, I just realized that I didn't print this out for them. Jeez. So I'm going to have you go.
We get a lot of steps into that. Sounds
Yeah, sorry about that.
No, you're totally fine.
3 miles.
I mean, you're not wrong, but.
Did you say 3 miles?
3 miles. How you
Do you
got
know how long
How you
3
got
miles
how you
actually
got
is?
But he finna walk more than this. I know you finna say some more.
I forgot to camera look right now.
Who's good?
What?
Can I go get a Band-Aid?
No, never allowed to get Band-Aid ever again. Hey, you know there's some Band-Aids on my back counter, right?
Oh
Or
my
back
God.
bookshelf?
That was the best thing right there.
Damn, bro.
James. Right there, James.
I thought.
James.
They don't matter.
Yes.
Why?
Okay.
I'm sorry.
Got it. Everybody.
All right. So, Mr. Hobby, once this finishes printing, please grab it.
Corey, when your birthday?
All right.
28.
No, like what day?
A
Saturday.
lot of things.
So, really quickly, Mr. Hobby is printing this out so that you have a record of this, and it can help you. But, eyes and ears right here. Christine. She has 2x squared plus 12x plus 10. What form is that in?
That's standard.
Standard. The textbook will sometimes call it general, but we call it standard form for the most part. So what do we know from standard form right away?
The formula. Oh, the Y.
2x squared. Okay.
Concavity, right?
The equation.
And this is concave what? Up. Like a? Right? A is positive 2, so concave up like a cup. And what else do we see?
The equation.
Remember, what do we know about every y-intercept that has and will ever exist for all time?
That x is 0.
That x is 0, right? Notice, what is this term going to become?
0.
This one?
0.
So 0 plus 0 plus
0.
10 is 10. That's why C is my y-intercept. Now, at this point, is that enough information for you to stop and sketch out a graph?
Yeah.
Yeah, that's all that's highlighted. Now, I need to caution you because once again, I told my first block this and they ignored me. Would this graph be acceptable?
No.
Well, sorry, I should also clarify. 2, 4, 6, 8, 10. It has the right y-intercept.
No, we just.
It's concave up.
One of the vertex.
But remember, that vertex is not usually the y-intercept. That's the one thing I said don't do. You can do something like this.
Right.
You can do something like this. And that's going to satisfy the target portion of this test, or this demonstrating understanding and test. However, we did discover how to find, sorry, that's the video to help y'all on Wednesday, how to find that vertex. Now, remember, Vakari, you were like, hey, Mr. Kennedy, I'm not comfortable with that, right? Do you have to be able to find that vertex yet?
No.
No. However, it is going to help you a ton to go ahead and start practicing it because you're going to use it a lot next unit. Let me say that again. You're going to work on going from standard to vertex form next unit a whole lot. So I would go ahead and start practicing it even if you're not going to do it on the test. What did we find out? So first off, what letter do we always use for vertex?
A.
H and?
Oh, vertex.
Vertex, yep.
My fault.
How do we calculate H from the standard form?
B and C. Oh, I don't even remember, I ain't gonna lie. You was shooting enough.
Opposite of
B
B
equal H, K, C.
divided by
Oh.
2A. So,
okay.
hey, this is what we did last Friday, and I know you weren't feeling well. H is the opposite of B divided by 2A. That's what we found out. That's in that Desmos activity. If you're looking at it, you're like, Mr. Kenny, where the frick is that coming from? One, that's not something, that's one of those rare things I'm telling you, you have to just know it. That's how we calculate H from the vertex form, or H from the standard form. That is, it comes from a calculus concept is the easiest way to see it. So in this problem, what's the opposite of B? Or what is B?
12, do it.
12.
12.
So what's the opposite of B?
Potato 12.
Divided by 2 times, what is A?
8. Two.
2. So what's negative 12 divided by 4?
Wait, negative 6. Oh, negative 3.
Right, 2 times 2 is 4. 12 divided by 4 is 3.
3, I'm sure.
So last thing I'm going to point out here is, if I substitute H in, if my H is my input, what's my output?
Okay.
Your K. So if I want my vertex, as long as I can find H, I substitute H in and I get what out?
Okay.
Okay.
So, once again, do you have to know this for this test?
Yeah.
Not for this test. Next test? Yes. So I highly recommend going ahead and practicing this now.
Miss Kenny,
Wait.
So,
What did you test again?
it's on Wednesday.
Okay. Thank you, brother.
Miss Kenny, can I ask you a question? Can you do like a little video to demonstrate on how to find the vertex and those
You know?
things?
I think I can.
Okay.
I think it's already uploaded.
I think he did it Friday game.
He did?
Yeah.
So one, I recorded Friday,
I
but two,
went here.
last week, because my first block was testing today, I actually did a whole bunch of the problems from the check your understanding. So I already gave you the solutions on check your understanding, right?
On how to find the vertex?
I actually worked through a whole bunch, and I'll show you in a second so you can see it, but I worked through a whole bunch of the check your understanding questions and uploaded a video on it. Okay.
Yeah, I think I saw it yesterday. but
All
I
right.
don't know if it-
So,
it's a
anyways, notice what's my vertex?
Your vertex is, I can't see.
Eyeballs are helpful.
No, Lopez here. Lopez.
So, -3, -8, with a y-intercept of 10, 2, 4, 6, 8, 10. Notice, again, do you have to have this level of detail for the test?
No.
Nope. But is that extra information for sure? Yeah. So if you can find H, you substitute H in, you get K out. I will also point out, and this is actually why it's useful, I can now write the vertex form of this equation. I can actually write the vertex form of this equation. What is A in this problem?
2.
A is 2. What is H? H is,
3, negative 3.
so it'd be X,
Plus 3.
and then K is -8. So notice, if I can find my vertex, I can convert this to vertex form. That's something to keep in mind here. Alright,
Alright.
you good, Ian?
Keeper.
You good?
Let me tell you.
Yes.
You sure?
I don't think she's okay.
I don't think she's okay either. Alright, so, again, all of this down, do you have to do it for your test?
No.
No, just y-intercept concavity.
But that
That's
gives
it.
me a CCC though.
Well,
What is it?
actually, if you justify it well,
Yeah.
just here up is a CCC. All of this with the vertex, that's that CCC plus, right?
Right.
Clear, consistent, convincing evidence,
Right.
plus on top, right?
Right.
Going above. All right. Whew. We're almost done with this so that we can get started with the stuff you cut out of the book. The last thing I want to point out here is Kate. Okay? Really quickly with Kate. I can't remember if it was just
Little extra.
guys, right here. What Mr. Hobby's passing out is this right here. And it's based on something in the book, but I slightly changed it to be better for learning. All right,
Oh, yeah.
Kate, what form of the equation does Kate have?
We looking. She got factor.
Factored form.
Yeah.
What should we be able to see right away from factored form?
The roots.
The roots?
Yeah, the roots.
What's R1 in this case?
5.
Oh, guys.
Negative 5. Oh, yeah, negative 5.
That's why we write that equation above it. Remember when it's x minus h, x minus r1, x minus r2. It's another thing first block forgot. We need the opposite, right? We always need that opposite. So R1 is a negative 5. What's R2?
Negative 1.
Okay, so we've got our roots.
Yep.
Now, I want to point this out. I think we talked about this last week in this class. I don't think I got there in 4th. But if here's negative 1 and here's negative 5, right?
Yep.
What is this that I'm drawing in right now? Why do we know that that line is symmetry?
Can we call Alexis Lopez for checkout, please?
She's on the way.
Thank you.
Why do we know that this negative 3 is that line of symmetry?
Because it's equal, it's equal in between jump.
Oh, come on, I need a better math term that it's equal in between.
That's bad vocabulary.
It's what?
Wait, you said what happened? Wait, what was the question?
Why do I know this is my line of symmetry? It's in the, it starts with an M.
Middle.
It's in the middle, right? When you say, sorry I missed that, when it's in the middle, right, it's equal on both sides, but when it's in the middle, mathematically, how do I find the middle of numbers? It starts with an A, an average or a mean, right? So, notice, what did Christine do? She took her two roots and she added them and divided by
1. I mean 4.
2, dog. How many numbers she just add together? Dog, how many she add together? 2, right?
Yeah.
And so she averaged them. Okay?
He was doing math.
Negative 5 plus negative 1 divided by 2 is negative 6 divided by 2, or
3.
negative 3. Notice that's right in the middle.
Yeah.
Please note, because again, students trying to memorize this in first block, which again, this is the extra, you don't have to have this, but you don't subtract them, you add them, because we're averaging those numbers.
Yes, sir.
So, H,
You said we don't subtract, we add.
because it's an average, right? It's in the middle. So H is negative 3. And if I substitute H in, what do I get out?
Okay.
K. So G of negative 3, negative 3 plus 5 times negative 3 plus 1. And so my input in negative 3 has an output of negative 8. Hey, does that look familiar to anybody?
Yeah.
Did we just do that right there?
I think we did.
That's the Y value, man.
We did that. You just said that's the Y.
So, hold up. What does that tell us about Christine and Kate's equation?
They're equivalent.
Different.
Oh, what's that term?
Equivalent.
Equivalent, right?
That's right.
They look different. One's in standard form, one's in factored form, but they are what to each other?
Tell the same thing.
Equivalent. Okay? So don't forget, they are equivalent. Okay. So, this is not that very necessary at all, go into vertex form from factored form,
Yeah.
but you can. Okay? We're almost done. Last thing. I want to remind you of this. Does anyone remember from last week how we took a factored form and rewrote it in standard form?
Where did y'all do that?
Did we do this on Friday?
All years.
I don't even remember that.
Oh,
There was something with like terms. There was some kind of model that I recommended. The area model.
Oh,
Yes, okay, so remember, you can just distribute, right? But what model do I recommend for that distribution?
And then that square with the 4 boxes?
Is that area model.
Yeah.
So this is just distributing. But what I recommend is, and you'll see this come back up,
Yeah.
is my area model.
Yes, sir.
It helps me distribute. What is x times x?
2x. I mean, x squared. My fault, x squared.
What is x times 5?
5x.
When we do that?
1 times x.
1x.
Friday. 1 times 5.
5.
Now, look.
I don't remember this.
Hey, you probably did it this way last year. X times x.
Yeah.
Oh, that's that x squared.
Oh, yeah, I remember that.
X times 1 is.
Yeah.
This area model just helps me distribute. It's x times x plus 5. It's 1 times x plus 5. It fills in the area.
I remember that.
And then we've got like terms.
6x.
So, I still have my 2. And then I have my x squared plus, what's 5x plus 1x? Plus 5.
Yes,
And then I just have to distribute again.
yes.
So f of x equals 2x squared plus 12x plus 10. Hey, does that look familiar?
Yay!
Uh-huh, yeah, you do.
Where
Look very familiar.
Yeah, where is that?
It's on the board.
It's standard.
Is that same? It was what Christine's
It's on
formula
that, it's on that
was.
board.
Oh yeah, because what were those two functions?
Equivalent.
They were equivalent, right? Notice what I have shown is by distributing, I went from factored form to standard form. Hey, really quick as a reminder, this is the only what's the word I'm looking for? Transformation you have to do. You have to be able to show me how to go from factored form to standard form. On the assessments. You have to be able to show me today and on the test. You have to be able to show me how to go from factored form to standard form.
Whoa, that's a quick move for me.
Huh?
That's a quick move. I wasn't here Friday, you know, so.
Did you watch the video I uploaded?
See what happened.
See, so
Let me tell you something. Let me tell you something. AT&T cut my internet off.
Okay. So,
Don't you got data?
here's what we are right now. Listen. We are going to have an assessment on you being able to identify the key features based on an equation, and then from those key features, graph that function, okay? So you have cut out 9 equations, you have cut out 9 graphs, I know there's only 6 shown here, but your job at this point is to identify which equations go with which graphs. Now, I will point this out. Just looking at a graph, do you know what form it should be?
Something, no.
Yo,
Wait, oh, just looking at the graph. Form? No.
it's standard.
See, I would have thought vertex
Yeah.
or factors.
I don't
You
think
don't look like Bertie.
My point is this. Have we ever gone from graphs to equations?
No.
Have we gone from equations to graphs?
Yeah.
So if I were you, I would actively look at, with my group, I would talk about I. And I would probably, and this is just an example, but I would identify what features we can see from I and try to find that graph together. Actively talking and helping each other grow and learn. Does that make sense?
Yes. Yes.
Questions about this? So, actively work with each other. You do not need to go to vertical surfaces yet.
Yes.
However, once you have worked with each other and paired all these together, right? And by the way, notice how there's space at the bottom? Almost like we could glue these equations there.
Oh, that's neat.
Okay, so we're going to eventually glue these. Do not glue until Mr. Javier or I confirm that you're good. But we're also not going to confirm you're good until after you have all of them. And we're going to tell you, hey, maybe I'd look at these again. Because we want you to think. By the way,
Yes.
this is going to be part of a non-calculator portion of the test because I need to see that you can look at an equation and know the key features, okay? So no calculator today. You need to talk about the key features based on this equation. Does that make sense? All right, let's actively work with each other. Mr. Javi and I are going to be coming around supporting you. You can have your Frere models out if you want as notes, but let's get after it. What's up? Hold on, let me pause this, and then yes. So I need to actively. It's like this. It's what form? Factored form, right? And remember, I pointed out a couple of key details to help us know the name of the form, because what's happening between the 3 in this binomial and this binomial? Multiplication. They're being multiplied. Because what do we do with factors? We multiply them, right? It's called a factored form because we are multiplying those features.
Yeah.
Guys, you got to know that. And when I'm looking at a lot of us, looking at, which one is it? This A right here, and not recognizing that it's factored form, that's going to be a problem. And once you recognize that it's factored form, are you taking the time to write out the equation above it?
No.
Because that's a key thing to help you identify what those features are. Right away, when I line it up like this, A is 2, so this parabola is concave up,
Like a cup.
like a cup. From there, When I look here, how does it go from x minus r1 to x plus 1?
It was opposite.
Because I need the opposite. So root 1 is negative 1.
Yep.
Hey, J-Mike. Camera right here. So what is R2? So my x-intercept would be negative 1, 0, negative 5, 0. Which graph goes with equation A?
Question A.
What equation A?
B. B.
Graph B?
B.
Hold on.
Okay?
Yeah, B.
Guys, did you take the time to write these things out? I cannot emphasize this enough, that if you're just trying to look at an equation, Preston, just because I see you and Brady trying to communicate instead of paying attention, if you just try to stare at an equation, you're going to struggle with it. It's not one of those things that you have to or should feel like you can just stare at the equation and know everything. When I look at this function, it's a very different problem, but what should that remind me of immediately?
C. That could be, yeah.
Huh?
He said standard.
What should this equation
Standard
remind me
form
of?
because we need to go,
No.
that'd be standard, right?
No, it's versus.
No, but see, you see the X, right? Oh,
3 halves x plus 4.
that's standard. Right.
Say again? Thank you, that's slope-intercept form of the
Okay.
line, guys. That's not quadratic. Is there an x squared in there?
No.
That's not quadratic.
Oh, I had a brain for it.
We got to pay attention to these things. Y equals mx plus b. And that's going to help me remember, hey, what is b in this case? I write out that equation below. What is b?
Linear. Oh, yeah.
No, but like, what does it mean?
The linear.
The y-intercept, right?
Yes.
Because again, this is the slope-intercept form of line. That's my y-intercept of 0, 4.
Yeah.
What's this 3 halves? That's my slope, or the...
Change the y by change x.
Right? If I write that equation below the 3 halves x plus 4, does that help? Now, Bakari, I want you to pay attention to this because I get a lot of students doing this. Like we just assume, oh, it's got to be quadratic because that's what we're working on right now. However, we did linear and exponential. If you take the time to write out a quadratic equation above it, does that look quadratic? Does that look like that standard form? See, this is why we don't just go gut instinct. We don't just memorize. We take the time to write out the one that we think it is, which means you need to know the equation so you can write it out above there.
Right.
Because if you write out any of the quadratics, it doesn't look like that. In the same way, if I gave you this function, what should that make you think of? What? Exponential, but what was that exponential equation?
Y equals A times B times, to the A.
Okay. And then we want to remember that that exponent is that repeated multiplication. Guys, write out your equations. I can't say this enough. Like, if I hadn't ever said that, I would understand us not doing it. But it's frustrating, and Mr. Hobby can attest to this. Every day he's here multiple times a day, right?
Yeah.
Do the majority of students write this out?
No.
But it's a very simple fix, guys.
Yeah.
Like, write out that equation. I'm not trying to make you do more work. I'm trying to make you work efficiently so that you don't get it wrong in the future. Because I'm tired of people saying, well, math has always been a struggle for me. Well, have you done the things I've asked you to do to change that? Because I know you're capable of it. But are you changing so that you can be successful? Or are you continuing to do the same patterns you've done in the past? Because if you're doing the same patterns that held you back in the past, it's not going to help you move forward. Take the time to write these equations. Now, we need to finish this up before the end of the day. You are supposed to have a demonstrated understanding. And I'm making an executive decision here I was going to talk about with you. Your test is Thursday, okay? Not Wednesday, because y'all desperately need this practice. However, y'all need to put in some time and effort between now and Thursday, because we are going to practice tomorrow, but I'm not going to be here Wednesday. I will leave an assignment for you, and you have plenty of check your understanding assignments, but I need to make this clear. If you do not do those things, that test on Wednesday is going to be, or on Thursday is going to be rough. Not because it's actually hard, but because we haven't learned the things we need to learn. I need us to study. I need you to practice. You're super capable, but are you doing the things you need to be successful? I need you to reflect on that. And if you're not, I need you to change it up.
Yes.
We've got 16 minutes left. I need you to work efficiently. I need you maybe to get out your notes if you're struggling with these forms. Identify the form first. I said that from the beginning. You gotta identify the form. Then from the form, right, you can find which features you have. Do we understand what we're doing for
Yeah.
the next 16 minutes?
Yes, sir.
Let's get it.
But I do need to remember.
Through a couple of these to make sure that these details are clear.
Was it not on?
So, as
His number
I
wasn't
already pointed
recording.
out,
We don't record
guys,
during.
write
Report?
out the equation
That's what he's
above
talking.
it every time. Every time. Like legitimately, what I would have done on B here is I would have written out ax squared plus bx plus c, and maybe below I would have noted, okay, concave up, and 0, 6.4 is my y-intercept. Now for all of y'all that were freaked out about that pi, did that pi for b actually matter in this equation?
No.
Not at all.
Not at all, so don't sweat it, guys. Can you use it? 100%. However, if we are talking about a quadratic in standard form, we don't have to worry about that. Now, I'm just going to go through these standards. I'm going to show each of them really quickly. Were there any of these that you have questions about still? Do not forget, because someone was asking me, hey, Mr. Kinney, what do we put in these spaces down at the bottom? First off, if it was standard form, did we have to identify the axis of symmetry? No. So do you have to put something there? No. X-intercepts, do you have to identify the x-intercepts for standard form? No. What do you have to identify for standard form? The concavity, and so if I were you, I would just write down A determines the concavity, and the y-intercept is 0, c. But again, that's also something you should already have in your notes.
Yes.
But guys, we got to practice with these things. Okay?
Who wants to work? Okay.
Factored form. Now, really quickly, I want to point out two things. Hey, guys. Two things I really want to point out here. Factored form. Do not forget, when it's x minus r1 and x minus r2, the roots need to be what? The
You're signing.
opposite. X plus 1 and x plus 5. X is actually equal to -1 and -5. Now, do not forget, I want y'all to pay attention to this. Have you noticed that we only ever need the opposite when it's x minus something?
Yeah.
Every time it's x and then something, it's x minus and I need the opposite. Every other time it's a plus. And it just is what it is. Now, I want us to look at this, Amaya, right here. I want us to look at this equation C, Amber. I want you to notice, how many roots do we have? For C, how many roots do we have?
2.
We have 2, but they are what?
The same number.
They are the same. Say that again. This is going to prepare us for the future. Because it's the same root twice, we're going to call it a double root. Notice how it ended up being the vertex. I don't see 2 different roots. I see one x-intercept where it is a double root, where it touches and bounces away. Hey, guys, I'm trying to connect an idea here so that this makes sense. I want you to notice, I could have rewritten this as x minus 3 squared.
Oh,
Now what does this look like?
Vindicated. Oh, I don't think I got a factor for it.
Yeah, I got a standard form and I got the birthday.
It's on the back of the.
Well, it didn't print out for some reason. We'll worry about that later.
Oh, it's on the back of this.
Did you do one-sided?
Oh, yeah, I don't got that.
thought I did.
But it was supposed to be two-sided. That's probably the issue. Because there was, yeah. All right, right here. Hey, regardless, focusing on our learning right here, I want you to notice how I can rewrite that x minus 3 times x minus 3 as x minus 3 squared. And what does that now look like?
Copy.
What does that now look like?
Ball game.
It's like shit.
Doesn't that look like x minus 8 squared?
Yeah.
Okay, so this looks like what form now? Vertex. That's why my vertex is at 3, 0. Finally, I cannot emphasize this enough when it comes to vertex form. Guys, do not ever tell me that this -4 is my y-intercept. Can't tell you how often I hear that. What is -4 right here?
Oh, that's your, what form is
Yeah?
That's your 80.
Not H. That's the y value of the vertex. Okay. Guys, with vertex form, do you see the y, excuse me. With vertex form, do you see the y-intercept without a whole bunch of work?
No.
No. You've got to know that. All right. So, we are packing up. I need to collect cards. If you could come put your cards up here, that'd be great.
Don't put names on it, right?
Bobby.
No, you have cards. Oh, I'm sorry.